Okay, we're looking at, in the book, on page, what page is that? That was page,
Stupid phone won't turn off.
that was page, yeah, yep. Page 1069. 1069, got it?
How do you find the page?
Huh?
Page?
Okay, page 1069, it talks about, and you should have looked at it when you were doing your homework, you should have seen it,
Oh.
because there was questions about it. First of all, do you know how many BTUs are in a ton?
288,000.
288,000.
Right?
To
How much?
12,000.
That's in a
12,000.
Oh, that's refrigeration. That's a ton of refrigeration, I think.
Thunder up there.
A ton of refrigeration is 28,000. I mean,
Ton of air
28.
conditioning.
What?
It's a ton. It's a
It
ton.
would be 288,000 if it was BTUs per
Day.
24 hours. Yeah.
Oh, okay, yeah, that's the other one.
Which is 12,000 BTUs, okay, per ton, right?
So that's the ton.
Ton.
Yeah, 12,000.
Ton.
That's a ton of
Okay.
BTUs.
Per ton. Okay. How many CFM in a ton? It was on the PowerPoint yesterday. Do you remember? What?
Two.
Do I just not even
Here, we'll go find it.
do the PowerPoints anymore, huh? It just goes in one ear and out the
They
other?
come in handy when we do that study guide. Feel me?
You mentioned one,
One CFM?
once.
Air distribution.
Okay,
Oh, he got it ready. Per ton?
these are things you're gonna have to know for the rest of your life, okay?
There you go.
Okay? These questions are even on the contractor's exam for California.
Damn.
They wanna know if you know how many CFM in a ton of air conditioning. And they also wanna know if you know how many BTUs in a ton.
CFM stands for cubic feet per minute, right?
Yep. You got it.
Does it?
Okay, so we figured out CFM, and we know what CFM is volume, right? So we are looking at a couple of different formulas that we're gonna look at.
That's what I'm trying.
No, yeah, I asked.
We got a sidebar conversation going on? Should I
It was
do
about the CFM meaning. Senior.
So you remember what Q is?
Total.
Right there, total heat.
I was gonna say that, but I wasn't sure. Maybe it was a trick question.
That's a trick question.
Yeah. You feel
Okay,
me?
Q is equal to
The temperature difference.
1.08 times CFM. Right? We got that?
Mm-hmm.
We're in the book, right? Are we in the book?
1069.
Times, okay, what page is it? Double check here.
What you do?
Times
30, this is 35.
TD. Now, what is TD?
Temperature difference.
There you go.
Ah.
Ah. Some people been doing some stuff. You been doing some stuff on centigrade?
No, but I've been reading it.
Okay, so that's what Q is gonna equal. Okay, so when we talk about CFM per ton, 400, right? 400 CFM per ton, right?
Mm-hmm.
We're talking about air conditioning. Air conditioning, all air conditioning is 400 CFM per ton. That's just the way it goes, okay? That's the way it is, okay?
Mm-hmm.
Okay, but if you're talking about heating in fossil fuels or in butane, propane, what happens is they wanna reduce the CFM for the heating cycle. So the blower speeds are turned down to medium or low, depending on the application. So, can you give me a reason why we wanna slow down the airflow and heat?
So we don't have a big heat,
That's dangerous.
Cause you don't have a big heat?
too big,
I think it's hazardous. maybe.
controlled,
No.
controlled hazard,
No,
no.
no. The more velocity, as air increases velocity, it has a tendency to cool down warm air. So with that velocity, of high velocity and more movement, the air tends to get cooler. So it feels colder because you have more draft. So what they do is they slow the fan down, so it's just kind of enters the room without anybody noticing, let's say, okay? But here's the problem, because it's low speed on the motor or medium speed, and each application is gonna be different. Each manufacturer's gonna have different motors and stuff like that. We don't know what the CFM is, that's why we have a formula to figure that out. And this formula, which is the same formula, CFM is gonna equal
Total heat,
Q
told you.
divided by 1.08 times CFM. No, total temperature difference,
TD.
TD.
I was about to say.
Let me correct that. Let me turn my smart board on and delete that. Temperature difference. Okay, so that means that if you're working on heating equipment, which you probably will someday, right? Not just air conditioning, we're gonna work on heating, right? Okay, one of the things we do in maintenance is we take the TD of that heater. Because on a nameplate, it's gonna give you what they call a temperature rise. Temp rise. Okay, and a temperature rise will probably be, it could be 45 to 70 degrees. I'm just saying, it could be anything. So that's the data plate that's on the unit. It's gonna be, so you want that heater to land in there, in that. So sometimes they'll also say that maximum bonnet output, max output, DUT output is, it may say 70, may say 100 and, I'm gonna put 150 degrees. Okay, so your maximum is you're gonna look at those numbers. So if you're going past the 150, if you got more of a temperature rise than 40 to 70, if you've got 75, or if you got 75 degrees temperature rise, you got an issue there that needs to be addressed. Because that furnace is overfiring, and we don't want the furnace to overfire. Das ist Feuerspulen. Und wer das roten anschlappend. Okay, so that's what we're gonna do when we do maintenance and when we do troubleshooting too. We're gonna check the input and output air on that furnace. Okay, let me close the door. You keep looking at that.
Who?
I don't know. I can't see. Okay, so we're gonna check the furnace at the output, we're gonna check the supply air, and we're gonna check the return air. So if we've got a return air of say we got 68 degrees return air, and our supply air is 130, let's say. Okay, what's our temperature difference on that?
Sixty-two. My bad.
62, you say, right? 62, okay, as far as maintenance, when you're checking the furnace out and cleaning it up and dusting it off and taking it apart, looking at the electrical and stuff, that's one of the things you're gonna check for. You're at 62 degrees, you look at the data plate, and you make sure it's within those two numbers, right? Okay. Simple, right? So you're good to go, you're not overfired or anything. So, if, for instance, you had a low temperature rise, suppose you were down at, let's see, 100. Suppose you got 100 degree on supply air temperature.
Dang.
So what's your temperature difference now? 32?
Yeah.
32 degrees. Okay, in this case, if you were checking it and you looked at that, you'd know that there was something amiss. Okay, so probably you would need to go to the gas valve and check the gas pressure coming into the gas valve to make sure you had the correct gas pressure to try and get that up there. On the other hand, if you were up here and you got a 140 degree supply air, what do you got for a temperature difference on that?
72.
Huh?
72.
72 degrees, okay.
Well,
Bam. Again, you got something, you got an issue there. So one of the issues that might be on this furnace might be the air filter. So you're restricting airflow. There's not enough airflow going across, or it's fired too high. Or the gas, you need to adjust the gas pressure to reduce the fire on the furnace. Okay? So that's one of the important things that we do when we check these temperature difference. So it's not like something we're just gonna do because it's in the book. So we're gonna have to know what our CFM is, and we'll go back to our example here of 130. So we change the filter, and guess what? Temperature rise went down, right?
perfect. Yeah, 62.
So that, there's more, so that, it could be as simple as that, could be collapsed ductwork, could be anything else too, that's giving you a high fire on that. 52, you said. Okay, so you're on the data plate, you're also gonna see, output, your BTUs, and we'll just say, for instance, a 60,000 BTU furnace. Okay? So, if we know what our BTU is, and we know what our temperature difference is, we can plug that into one of these formulas, especially this one, because we're looking for CFM, right? Okay, but we can plug that into those formulas, so the total heat is 60,000 BTUs, right?
Yep.
So we can do 60,000 divided by what? 1.08 times 62. And that'll give us our CFM for that air handler in the heating cycle.
Okay, yeah, that's way off.
Way off.
What I did.
The
What did you get?
I got 3,444,444,444,444.
What kind of an answer are you looking for?
that formula right there.
Do we have to do the multiplication first, then divide it?
Probably.
I got 896.
Yeah, if you do the other.
Yeah, I did, I multiplied it first and divided it.
That's the easiest.
Okay.
So what do you got? Anybody get it? Anybody get something different? So what's 108 times 62?
66.96.
Yeah.
0.96.
86.96 divided by 60,000.
OMG.
Oh my.
Goodness.
Okay. So what do you come up with?
896. You get 96?
896.05.
896.
Yeah.
So our CFM is gonna be 896, right? And that's gonna be our CFM. So our CFM on this dude here, 896. Okay, so now we figured out what's the CFM. Now, if this happens to be a, hooked to an air conditioner that is a 3-ton, how many CFM in cooling?
1200 CFM. Crazy.
How do you get that?
You just divide the 3 to the CFM, because it's 400 per ton.
Times 95.
I mean,
I would multiply it.
my bad.
I would multiply 3 times 400.
Yeah, I would too.
Okay, so in the cooling mode, we have CFM of 1200. So obviously, we have less CFM in the heating mode, right? Okay. How's that grab you?
Alright.
Aye?
Aye.
Okay. So, since you know that now, boy, I have a job for you.
Lab?
I've also got a PowerPoint that we're gonna talk about, we're gonna go into some blueprints and talking about some blueprints. So I got this PowerPoint going on here.
Can you do anything with the, since there's 5 tons and 60,000 BTUs? There's no, you wouldn't do anything with the 5, right?
The 5.
5 tons.
What do you mean?
Because if you divide like 60,000 by the 12,000 BTUs, it gives you, there's a 5 ton, that wouldn't matter, right, because it's 3.
How many BTUs in 3 ton? How many BTUs in 3 ton? 36,000. 36,000. You need 3 ton, right?
How do you get that?
You just do.
12,000 BTUs per ton. Go back
Oh,
over
three-
here.
three-
remember?
Oh, 3
Yeah,
times.
3 times.
3 times 12,000.
Well, that's too much information, huh?
No.
No, I was thinking a little
This is
more
basically math, honestly. It's not
easy.
that bad compared to what we did yesterday.
Okay, so we got that, and we're gonna be doing things here today.
Be doing big time.
Yeah. So let's get rid of all this,
Let's put these brains to work.
and then we'll do this. We'll do this one PowerPoint, then I'll give you this assignment.
Section.
Since we're rolling. Rolling. Okay, there we are. Pow.
I like this image, Jeff. I like this one in the book.
You were never gonna do it for the class though.
Oh, that's how you find the video machine, okay.
Oh, let's see.
Yeah, what was the page?
I haven't been using the book.
Oh,
1069, the last number.
1069. Ah, it's right there.
1069?
Mm-hmm.
That's the equation.
Oh, there it is.
Why can't I
That is crazy.
One down there, one time.
Here we go.
There she goes.
Okay, you ready for this?
Nope.
Okay, this is a little presentation I put together called Designing and Layout of Ductwork. So we're gonna actually start with a floor plan. See that bad boy?
Yep.
That's a floor plan. Right there.
So we
Okay.
gotta make a floor plan or?
No, this is a floor plan. This is a floor plan.
Oh, I'm talking about the
This is
duct.
a floor plan from the book. Okay, if you notice this floor plan that's in the book, there is a stairway right here. I did some remodel. Okay, I turned it into a single story. Okay, so we know from the handout of the legend, right? Did everybody get one of those?
And then,
Yes, we did.
Typical blueprint legend? You got one of those?
Yes, we did.
You did?
As soon as we can find it.
Okay, so we know that we have got, this is a supply air plenum,
Plenum?
plenum, and a return air plenum,
Plenum.
Plenum, oh.
okay? And this is a return air
Plenum.
can,
How?
where the filter goes, it's in the hallway. Remember seeing that on the PowerPoint,
Mhm.
the return air can?
Oh, yeah.
This, if this was a rooftop unit, it would be, these would be the drops from the rooftop or into the attic. If it's a closet, like it is here, it's just the metal going up to the attic, let's say. And this ductwork is gonna be in the attic because that's the way I wanna do it. Okay, so now we have, on here, we have CFM requirements for each room. Right? Okay, so each one of these are supply air registers, right?
Yep.
Can you see them all?
It's right here.
I know they don't have X's in them, but they're supplies. Okay, first thing we do, we lay out, this is how we do it. You're gonna take, you got three sides of this plenum that you can use. Think about that. If these two plenums are together, you're not gonna get in between those two plenums to tap in a start collar for ductwork, right? So you've actually only got three sides. So think about that. So first thing we're gonna do, this is how I do it. You're gonna do it, when you're done, it's gonna look similar, but I always start off with the furthest register I'm gonna take on that run. So I just take the furthest one and I go straight line. And then from that, I'll go ahead and Y off to bedroom number 3. And I'll also Y off to, where?
Bathroom.
Yeah, wow. Let's see if I can get this thing to work this time. Bathroom,
Kitchen.
Y off to the bathroom. And anything else? Oh, the other bathroom. How about that? So each one of these is a Y. Okay, all different sizes, okay? So that takes care of this side of the plenum, right? Because we're looking at that ductwork, by the time it gets back to the plenum, we're looking at a pretty good sized ductwork. Because it's gotta taper down, remember?
Oh, yeah.
Okay, this side of the plenum, I'm gonna go and pick up that bedroom 1, right?
Living.
And the entryway, and then we're gonna go do the living room. Whoa,
And dining.
pow, right there.
Look at the dining.
Pow.
Dining. Crazy.
Okay.
Look at that right there.
So these two, yeah, I know we're kinda coming around in a circle, but sometimes can't be helped. Especially if you're, you know, it'd be ideal if it came off here, right?
Right.
But you can't get to that center.
Cause we have
that
3
one
walls
side.
too.
But you have to, yeah, you can't get in there. Okay, so that one, the last one would be the kitchen
The laundry.
and the laundry room, right? Okay, we've got them all?
Yes.
No. Forgot the return. Don't forget the return.
Crazy.
Whoa. So from the return plenum to the return where it can, right? So that's completed the ductwork, that's a layout, that's a pretty simple layout, and you make it as simple as possible, because you're gonna go as straight as possible, because moving air has inertia, meaning it wants to go in a straight line, so we're just making it go in a straight line, as straight as possible, right? Okay, since we did that, check this out. If those two plenums were coming down from the roof, you'd have the supply drop, right? See that?
Yep.
And then you'd have the return, right? So we kinda did the same thing, really, if that was the supply coming down from the roof. Now, if it was on top of a furnace and it was flipped around, the same rule would apply in Torricelli's law. That means that when you drop the air down in here, you want it to come off the bottom. So this dimension, right here, is gonna have to be the same on all runs, when you tap the collars in. Right, because this is what you want. You tap the collar in up here, guess what you're gonna have? Come on, what are you gonna have? What are you gonna have?
Weakest jet.
Huh?
The weakest jet.
What, you wanna put the collar in here?
Yeah.
And put it duct on there?
Yep.
What are you gonna have up there?
A weak jet. Weakest jet. This is right there.
What'd you say, a reject?
No, weakest jet.
Oh, yeah, see, it's gonna be weak, you're not gonna have much airflow out of there, right? So that's the reason, that's Torricelli's law. Okay, that's the reason why we do that, and you'll see that sometimes, you're just gonna come off the bottom, and if you come off this far off the bottom and tap the first one there, then you're gonna have to tap them all in, right there.
Mm.
That dimension, whatever dimension that is, as long as it's the same, we know that we're gonna get the same amount of pressure coming out there. That's just a little extra for you to get, okay? So these are just kind of things as far as installation and what we've come across and what I've come across. So we're clear with that, right? Good. Let's move on. Maybe not. I knew I should. Got batteries. Problems? Problems? Do you wanna know a problem? Do you wanna know a commercial problem?
We have to know.
You don't have to know, but
I
you
want to
can
know.
actually find this out once you get out in the field. I'm gonna tell you, typical, this is a problem that happens a lot in commercial building. This is a commercial building, right?
It's interesting.
Oh, you're gonna show something from here that's messed up?
No.
Oh.
I
Look at
believe
this
so.
stuff.
It would've been fixed by now. Okay. So. Okay, we have a,
You know what I used to do? I used to have an Xbox and I used to put mine in the freezer and they used to get cold. And I put them back in and they work.
okay, and it doesn't look like my clicker's gonna work now. Shucks.
Somebody has batteries right here.
These guys.
AAA.
So,
Well, we could actually stay over here and click it.
Pass me the mouse right here.
okay, so, I'll let you know.
Pow.
Okay, so typical office unit, here you got a supply run or return to the unit. You got a supply going here and a supply going over here, and it's blowing air throughout the office, let's say, right? Okay, that's fine, until they decide they're gonna make, oh, well, this guy's really got a big office, we need to get another office for this other guy we just hired, and they put a wall in there.
Sheesh.
So now they put the partition up here, guess what happens to that airflow on that side of the,
It has no return there.
there's no return, all the returns over here, right?
Right.
So this is like blowing air into a bottle. So the air stops, because it can't go anywhere, so it backs up, and the air's not gonna go anywhere, it's just gonna come here, and wherever it can find to go. So typically what we do is, we put in what they call a jump over, and it's already written up there, obviously. So this is a correction for that, we put in a jump over, it's just a duct that connects both sides of those. And it allows the air to come through this jump over and then back to the return. I've done that many, many times.
It's on a jump over?
Yep.
Is
Fixes
it
the
hard to
problem.
install it or
No, you just, it's right there.
just like that?
Yeah, just boop, boop, yeah. Connected by duct, of course. Okay, so that's a typical problem. Here's something else that you might wanna need to know. Roof pitch. So you got a typical rooftop unit on a pitched roof, right? So knowing how to get the pitch, because if you're gonna replace this stand with a new unit, or if you're gonna make the elbow, you're gonna give the information to the sheet metal guy, or if you're gonna do it yourself, you're gonna need to know what that pitch is. So in order to get the pitch, you need a level. So this is simple,
Do
this
you
is
have one of
simple
those?
stuff. Huh?
Do you have one of those here?
No, I don't have a level. Somebody has a level somewhere. Have you ever seen a level?
I have one in my car.
Okay. 2 foot? 4
Yeah,
foot?
I think it's 2, not that big.
Okay. I used to carry 4 foot. Cause the longer the level, the better, more accurate you're gonna get. So you level that on the roof itself. You put one side on the roof, and then you watch that bubble. See that bubble right there? You make sure it gets in the middle, and you measure from the bottom of that level to the roof. So in this particular case, it's 8 inches from the bottom of the level to the roof. So that means that it's 8 on 24. Or if we do 8 on 24, what is that, 8 on 24, what else is that?
3. Oh, yeah.
4 on 12. 4 on 12. You just reduce it down. So you got 4 on 12, that's a common term, it's a 4 on 12, 3 on 12, 5 on 12. Depending on the pitch, so find out what that pitch is, and the code in Fresno, as far as the pitch, anything above 5 on 12 needs what they call a work platform. Or a catwalk.
Oh, okay.
So it's gotta have a work platform, it's hanging out here, so you can stand on its level.
So it's like the 12 pitch or standard?
This is pretty common, 4 on 12,
Okay.
my house is 4 on 12.
No, I'm curious, I just wanna go to my house and try it too.
Yeah, you can. That's just a way to get the pitch. Hope you guys understand that, hope you guys get that.
Most houses are 4 on 12?
It's a common size, but not most houses. Most new houses now
Right
are
now,
5 on
looking
12.